In this video, we're going to examine how to write equations in slope-intercept form when we're given information. Particularly in this video, we're going to look at when we're given information as a graph. There are two methods we can use. The first is called point slope form, which says y minus y1 equals m times x minus x1. And where this means, you have a point, and that point is x1, y1, and you have a slope, and that's your m. And so what you would do is you'd plug in the point you're given, plug in the slope, and to convert this to slope-intercept form, what you'd have to do first is distribute the slope and then move the y1 over and combine like terms. And we're going to look at that method for it. The second method is to actually use slope-intercept form, because if we're given a point, we have an x and a y, and we're given a slope. In slope-intercept form, there are four variables, y, m, x, and b. If we have a point, we have an x, y, and we have a slope, we have our m. We can actually solve the equation for b and then write the equation in slope-intercept form. So there's two methods for it. I'm a big fan of point slope form because that kind of deals with the idea of translations, which we're going to dive into the further and further we go in the unit. A lot of people are fans of method 2 because it's a quick solving equations approach. Worst thing you have to do is get rid of a fraction coefficient. So we're going to take a look at both methods in some of these examples, and you could choose which one you want, but you have to know both just in case there are certain problems on the test. So the first example, write an equation in slope-intercept form given this graph. So if I look here, I'm given 2 points. I'm given 3, 2 with 4, negative 1. I'm not given the slope here, but I can actually find my slope. So my slope in this problem is rise over run. I'm going down, it looks like 3 units, so negative 3. I'm going to the right 1 unit, so positive 1. So negative 3 over 1, so my slope is negative 3. So I told you I'm going to do maybe on a few of these both approaches. So let's do method 1. And method 1 says start in point slope form. Y minus y1 equals m times x minus x1. Now, x1 and y1 are points on the line. I'm given 2 points. I can choose whichever ones I want. So let's choose 3, 2. So that means my x1 is 3, my y1 is 2. So I have y minus y1, which is 2, so I have y minus 2. M, which is my slope of negative 3, parentheses, x minus x1, which is 3, so x minus 3. And this is where I said before, what you would do is you would distribute the right side and get negative 3x plus 9, and then you would add 2 to move to the other side, and I would get negative 3x plus 11. And so that is the answer of the equation written in slope-intercept form, starting in point slope form. And so it looks like the general rule for point slope form is plug in your x1, your y1, your slope, distribute the slope, and then move the y1 term over. So now let's examine, method 2, which says let's start in slope-intercept form. And I'm going to use the other point just to show it'll give you the same answer. Here x is 4 and y is negative 1. So I plug it in, negative 1 for y. My slope is negative 3. My x is 4. And I'm solving for b. And so what I do is I do negative 3 and 4 is negative 12. So negative 1 equals negative 12 plus b. To solve for b, I would add 12, and I get b equals 11. So now if I want to write the slope-intercept form, y equals my slope of negative 3, and then I have my x plus b, so plus 11. It gives you the same answer. Even when I use the other point on the line, it still got the same answer. So either technique can be used, either approach can be used. I'm a fan, like I said, of point slope form. But if you like slope-intercept, you can use that. Just be familiar with both. So let's look at another example. Number 2. So here I have the point 3, 4.5. And so now we're going to find our slope-intercept form of this equation as we go through it. And so if I look at this one, you may say, well, I have my point of 4.5, but I don't have my slope. Well, if I take a look at the rest of the graph, I see the graph actually intersects the origin. So it goes through the coordinate 0, 0. So I do have another point on the line. And so I can find my slope. You know, I plug in, I can use the slope formula if I want. I have m equals y2 4.5 minus y1 0 over x2 minus x1, which gives you 4.5 over 3. And if I were to divide that and simplify, you would get 3/2. So my slope is 3/2. I have a point 0, 0. I have a point 3, 4.5. In this example, I'm going to do method 2, which is start in slope-intercept form and solve for b. So if I take a look, I need to find my x and my y. And in this problem, you're given two x and y coordinates. You can use 3, 4.5, but I'm going to use 0, 0. And the reason why is because if I plug in 0 for y, you know, I have my slope of 3/2, and I plug in 0 for x, what's going to happen is multiplying by 0 cancels out the 3/2. So 0 equals b. So I automatically know my y-intercept is b. So slope-intercept form, y equals 3/2 x plus b, you know, plus 0, but we never write a plus 0 at the end. So my slope-intercept form is actually y equals 3/2 x. And so now let's examine example 3. Example 3, we're given a point in the line as 3, 0, and it looks like this is a vertical line. For a vertical line, remember, slope is your change in y over your change in x, your rise over your run. And so here I'm going to have a vertical change, but I don't have a horizontal change. So I'm going to have a number over 0, which is undefined because you cannot divide by 0. And this is where you need to start remembering things. This is a vertical line. The equation of a vertical line is always x equals whatever number goes through on the x-axis. So the equation of this line is x equals 3. We cannot write a vertical line in a slope-intercept form because there is no y value to solve for here. So x equals 3 is your answer. The same goes with example 4 in a way, except for example 4 is our horizontal line. And so the slope of a horizontal line, slope being rise over run, change in y over change in x, you're always going to have a run. It's a horizontal movement, but there is no rise to it. So 0 divided by any number is 0. And so we said the slope of a horizontal line we learned before is always 0. So I can actually kind of think about that. If I do slope-intercept form, y equals mx plus b, you know, I have my coordinate, -2 for my y, I have 0 for my slope, I have 0 for x, and I have b, well then -2 is b. So then y equals 0x, which is just 0, plus b, which is -2. So y equals -2. The equation of a horizontal line is always y equals whatever number it goes through on the y-axis. So that is the approach for point slope form, slope-intercept form when you're approaching how to solve, how to create the equation of the line represented by being given information on the graph. You have the two approaches, point slope form or slope-intercept form. And we'll examine those approaches in the next video as well.